Hello, today will be a review of all the different ways that we can factor. So our first thing that we need to do with our factoring review is what is the first thing that you do in factoring. No matter how many terms we have, no matter what's going on, the first thing that we always check for, and the only first thing that we do if possible, is factor out the GCF. Sometimes there is no GCF and that's fine, then you just move on. But you should always double check and make sure that there isn't a GCF first. Next, let's look to see how many terms you have. How many terms you have will determine which factoring method you will use. If you have two terms that you are trying to factor, there are three different options of what you may have to do. The first one is difference of two squares. If we have the difference of two squares, remember the difference means we are subtracting, and two perfect squares. So we look here, 4x squared is a perfect square, 9 is a perfect square, and we have subtraction. The way we factor the difference of two squares, we take the square root of the first term. The square root of 4x squared is 2x. That's our first piece in each of our binomials. The square root of 9 is 3. That's the second piece in each of our binomials. And then 1 is a plus and 1 is a minus. Our second option is the difference of two cubes. The only difference between the cube ones and the square ones is if you have the difference of squares, it must be subtraction. If it's cubes, we can have subtraction or addition. So that's a little bit tricky, so make sure that you have that one clear. Difference of two cubes, difference means subtractions, and two cubes means we have two cubed numbers. So we look, we've got subtraction. 8 is a cube, x cubed is a cubed, and 27 is a cubed. When we break this down, we want to find our a and our b value. The a and b value are what numbers did we cube to get there. So to get 8, we are cubing 2, and to get x cubed, we are cubing x. So our a value is 2x. What do we cube to get 27? That is 3. So our b value is 3. If we have the difference of two cubes, our pattern is minus, plus, plus. So this becomes a minus b. Your a squared. We are squaring 2x, so that becomes 4x squared. You've got to square both of those pieces inside. Plus a times b. 2x times 3 is 6x. And then b squared. 3 squared is going to be 9. You are never going to be able to factor that trinomial. You can try if you want, but you're not going to be able to do it. Alright, our third option, if we have two pieces, is the sum of two cubes. The only difference between above is that we have two cubes, but instead of subtraction, we're going to have addition. So again, what number cubed gives us 64? That is 4. So our first term, our a term, is going to be 4x. What number cubed gives us 1? Sometimes this tricks some people. 1 cubed is 1. 1 to any power, no matter what, is going to be 1. Our sum of cubes pattern is going to be plus, minus, plus. Same pattern though, so it's going to be your a and your b, so it's a plus b. So 4x plus 1 times your a squared. Remember, we're squaring the 4 and the x, so that becomes 16x squared. Minus a times b, which is 4x, plus b squared, which is 1. Alright, moving on to what do we do if we have three terms. If we are trying to factor something that has three terms in it, the first thing that we're going to check for is to see if we can do regular factoring. Regular factoring has the squared, the x, and then the number. And with regular factoring, our a value is equal to 1. When that's the case, we are multiplying to the outside and adding to the middle. So we're looking for two numbers that multiply to a negative 10 and add to a negative 3. Well, that's a negative 5 and a positive 2. You want to double check to make sure that both criteria are met. So negative 5 times 2 is a negative 10. Negative 5 plus 2 is a negative 3. Batman is used when we have an x squared, an x, and a number, but our a value is not 1. After we've checked for a GCF, remember, always check for that GCF first. When we do this, our Batman method, let's go ahead and write this over here, give us some more room. We multiply the first term and the last term to get 24. We bring down that first term, 3x squared, and a positive 8. We are looking for two numbers that are going to multiply to 24 and add to 14. Those numbers are 12 and 2. We double check that. 12 times 2 is 24. 12 plus 2 gives us 14. Then we group the first two, we group the second two, we pull the GCFs out. So the GCF out here is 3x. We are left with x plus 4. The GCF in the second piece is 2. We're left with x plus 4. Remember, these quantities must be the same. The GCFs come together to form your first factor. That common piece is going to become your second factor. And some of you guys can do these in your head and you don't have to do Batman, which is fine, but Batman is always the method that you can use to get the right answer. The last method you could have if you have three terms is quadratic form. In quadratic form, we call it quadratic form because it's not a quadratic, because quadratics are raised to the second power, but it acts like a quadratic. In order to have this one, it must be to the fourth power, then to the second power, and then your number. Here, we're still going to multiply to the outside and add to the middle. That's why we call it the quadratic form. So two numbers that multiply to a negative 63 and add to a positive 2 are a positive 9 and a negative 7. The only difference is, normally when we factor a quadratic, it's going to be x plus 9, x minus 7. Because it's to the fourth power and then to the second power, it's x squared plus 9 and x squared minus 7. When you have the quadratic form, you've got to double check those two binomials that you're left with to see if you can factor those any further. Lots of times with quadratic form, you're going to have to keep going. And our very last method, when you have four terms, the only factoring method you could use would be grouping, if it's factorable. And grouping should be familiar because we do grouping in the second step of our Batman. We group the first two pieces together, we group the second two pieces together, pull out the GCF, they share an x squared, which means we're left with an x minus 3. Here they share a negative 4. We always want that x term to be positive. 12 divided by a negative 4 gives us negative 3. Those are the same, that's what we need. We take the GCFs to give us x squared minus 4 and x minus 3. Just like I warned you in the last problem, you've got to make sure that when you're left with a quadratic, you're still checking to see if it can factor. And this is the difference of two squares. So that's x plus 2, x minus 2, and then we bring down that x minus 3. So sometimes you got to keep going after you've used one factoring method and use another factoring method. All right, that is it for our factoring review.